little less in covering in 6 lectures. So I decided in my own way. So today I will take mainly fast solution of Poisson equations in Cartesian and cylindrical coordinates using finite differentiation. So let me go with the thing. So the agenda for today talk, let me select my pen first and then in color. So agenda for today talk is first I will tell you that classification of second order PDE. Then solution of Poisson equation in rectangular or in a rectangle and cylinder. So suppose I am given an algebraic equation of degree 2, which you know generally we write in the form of ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Then we say that it is representing it is representing if it is positive, then it represents a hyperbola. And if h square minus ab is negative, it represents an ellipse, and h square minus ab equal to 0, it represents what we call parabola. Now, keeping this in mind, if I take second order partial differential equation a du by dx, so my a could be function of xy plus 2hxy day 2u by dx dy plus b day 2u by dy2 plus 2g ux plus 2f fy plus c equal to 0. Then keeping the terminology of the second order, if h square minus ab is positive, then it is called hyperbolic, and negative, it is called elliptic, and 0, it is called a parabolic. Now this is not a big deal to know that what is when it is called hyperbolic, when it is called elliptic, when it's called parabolic. But let's come to the basic. The basic is that if I am given second order partial differential equation, then since my coefficient depend on xy, and hence in a given domain at some point my h square minus ab can be positive, at other point it could be negative. So in the same domain, same differential equation at different points or different region, it can be of different kind. This is one thing. The second is that why we are keen to know whether it is a hyperbolic or it is elliptic or parabolic, because it tells something about physics of the problem mathematically. So if my equation is hyperbolic, since h square minus ab is greater than 0, it will have two characteristics. And so the moment I know characteristic, if I want to solve hyperbolic equation, I can use method of characteristics to have a solution of the hyperbolic problem. On the other hand, if my problem is parabolic, then two characteristics, they will be coincidental, they merge together, and you will have parabolic problem. On the other hand, if my equation is elliptic, then there is no characteristics. And physically, what you understand is that if my problem is hyperbolic, meaning is that it is some kind of a wave equation. There is an oscillation in the equation. This tells me the physics wave equation, and you will be having some kind of this term in the equation because it tells you that there are vibrations. On the other hand, if my problem is parabolic, then you will have diffusion things and you have a term of the du by dt in the equation. These two problems, either hyperbolic or parabolic, they are initial boundary value problem. Initial boundary value problem. And you need initial condition as well as the boundary conditions. On the other hand, if your problem is elliptic, there is no characteristics, so it will be having a domain in which the equation will be valid, and that's why these problems are boundary value problem only. There is no time factor in elliptic equation. So you have either elliptic problem, which is nothing but your steady state problem. Now coming back to, so this is just to give you what is classification of equations, and this analogy is taken from the corresponding algebraic equation, but physically hyperbolic equation are associated with the wave equation. Parabolic equations are associated with what you call diffusion or heat conduction problem, and elliptic equation are associated with what you call boundary value problem, which are steady state in nature because there will not be any time dependency. Now suppose I am given second my equation in a rectangle uxxy plus uyy equal to fxy in a rectangle. In a rectangle, that is, I am given a rectangle in which my equation is valid. Now, without loss of generality, I can take this point as 0, 0. This is my A0. This is point is my 0B. And as you understand, this point will be AB. What I mean to say is, by length of my rectangle is A and width of my rectangle is B. Since my problem is, so my omega domain in which my equation is defined is a rectangle, I should be given a boundary condition. I will consider at the moment only Dirichlet boundary condition. So I am given uxy is equal to, I write f, I have already taken, so gxy on the boundary, that is the lines, this line and this line, this line and this, which are perpendicular. Two lines are parallel to, and another two lines are perpendicular to these parallel lines. So I have this. Now, yeah, I want to solve this using what you call finite difference method. Then I will first discretize my domain into a uniform kind of mesh, taking different in the beginning, different step length along x as well as in y direction. So for the sake of example, okay, let's it be no problem. So I have my step length h1 along x direction and h2 along y direction. So my rectangle is there, which I have my h1, h2 step length h1 along x direction and h2 along what do you call your y direction. Now what I do is that since I have taken this, my notation uij which I writing, it will be uxi yj, which is nothing but ui of h1 and j of h2. So h2 in along y direction and what do you call your x is along sorry, h1 is along x direction. So this will be my point. Now if I write my finite difference approximation of my equation, then my equation will become as all of you know, ui plus 1j minus 2uij plus uij minus 1 upon h1 square plus uij plus 1 minus 2uij plus uij minus 1 upon h2 square equal to f of xy, which I denote as fij. I hope everybody understand that well. Anybody any issue, please? Hello, everybody. Any issue about approximation?
Yes, sir. Just can you just repeat the last step, because I think that will clear this step. U x comma y is equal to u I h comma
uxiyj.
comma yj.
This is nothing but uij I denote, and
Okay.
my xi is nothing but ih1 because I'm going
In a
x
x
direction,
direction. Okay.
and h2 is in the y direction. So my yj will be nothing but
jh2.
jh2. That's what I'm writing.
Okay, okay. Then it's
And
okay, I think.
I'm sorry, please. I'm sorry. This is not j minus 1. This is I minus 1 j, and this is okay, right? I hope everybody understand. This is I minus 1 j. Okay. So this is my notation. Now what I do is that to make life simpler, I multiply both sides by h2 square. So what I get is h2 square upon h1 square ui plus 1j minus 2uij plus ui minus 1j. This is my first part. My second part will be uij plus 1 minus 2 uij plus uij minus 1 is equal to h2 square fij. Or more precisely, if I write this this way, expand it, but I write my alpha equal to h2 square upon h1 square, that is my alpha, then my equation will become just alpha ui plus 1 j minus 2u, I take that way, uij plus ui minus 1 j plus uij plus 1 minus 2uij plus uij minus 1 is equal to h2 square fij. And if I expand it, what I have is alpha ui plus 1 j minus 2 1 plus alpha uij plus alpha ui minus 1 j plus uij plus 1 plus uij minus 1 is equal to h2 square fij. So this is what I get. Anybody any issue, please?
No, sir.
Okay. So what I do is now, this is the I have my basic equation. Now I apply my basic equation in the interior points. So my rectangle which I have, I will be having, let's say, I discretize this way. So let's say I have n interior points along x direction and m points along y direction. That is, total there are m into n interior points. I can number them 1 to n here, then n plus 1 to 2n here, and keep on so, and then my last point will be mn, interior points. So this is n plus 1. So you have your interior points mn, where I have to form my equation because I want to solve in the interior of the rectangle. So when I do so, just see that if this is my ij point, then I will be having this point as I plus 1, this as I minus 1, this as j plus 1, this as j minus 1. And what I do is that I go first along x direction, that is the first line, which is I have drawn here. So I will go along this line, first line, then second line, and so on. So first n equation for the first line, then another n equation for the second line, then another equation for third line, and so on. And then I have my mth line, and total you will be having n equation for the mth line. So total equation will be mn. So when I do so, just see that my weights here is 1, because I have taken that way, I wrote my things that way. So my alpha is a weight of ui plus 1, alpha is weight of ui minus 1, the weight of j plus 1 is 1, weight of uij minus 1 is 1, and weight of uij is minus 2, 1 plus alpha. So that is what my weights are. So my this is 1, this is 1, alpha here, and 2 into minus 2 into 1 plus alpha here. These are my weight. So if I write my equations for the first line, please understand, I will be having something like this. If you try to understand, I have I just so just see that okay, no problem. I lost my thing, but no problem. I have this rectangle, and I have my weight 1 here, 1 here, alpha here, minus 2 plus 1 alpha here. This is the ij point, this is I plus 1j point, this is I minus 1j point, this is j plus 1 point I, and this is my ij minus 1 point. Now if I go from this direction first, then my equation will be something like this, because this is alphabet. So this alpha I will be coming for u0 line. This is 0 line, I call the boundary line. This is u0 line, plus I will be having what you call uh, minus 2 into 1 plus alpha. My I write u1 line. U1 means I write what is u1, plus you will be having something like u2. This is the second line, and you have what you call alpha of this. So I have something like this. You have yeah. Just a minute. So I don't have anything here. My things are alpha this. So I have I into u naught, plus you have a matrix T, which is u1, plus you have a matrix uit, and you have the vector f of the right hand side. If I line for the first line, what is my u0? My u0 will be this line, which is the boundary line. So this will go off to the right hand side because something is known to me. So I write f1, then this will be coming here. And what is T? My T will be a matrix of the form minus 2 1 plus alpha minus 2 1 plus alpha, and this will be alpha, this will be minus 2 1 plus alpha, this is alpha, and this is minus 2 1 plus alpha. Yeah, anybody any issue please about matrix T? Because my line contains alpha minus 2 1 plus alpha only. For the first point I get this boundary point which goes to right hand side, and similarly for the last point, this is the boundary point, so that goes to right hand side. Otherwise my matrix will be something like T if I write for the first line. Yeah, are you getting my point, or do you need some more explanation? Hello?
Yes, sir. I think a little bit more explanation in that way. You write this equation I u0 plus t u1 when we move from
Just
along
see
the
that
zero line.
this is my first point. When I take this point, I change the color of this point so that you understand. I'm using second, third time. So this is my first point, let's say. I mean
Okay,
to say, this is my first point. Then I will be having j plus 1 point here, j minus
right.
1 point here, because they are
Yeah,
bidirectional. My I plus 1 point will be this, and I minus 1 point will be this. Now,
right.
if I take these 4 points, then these 3 come along a line. This goes
Right.
to the next block because this is a one above it. So this is coming here, which is weightage 1 here. So I am writing I, and it is coming here. U2 means the whole line. So if I write this I, so I can say this is ij plus 1, or I write this as 1, then this will be n plus 1. This will be what you call n minus 1, and so on. So what I mean to say is I have this 5 point,
Now I
3.
understand a bit, sir. I think whenever you are taking a fixed point, I comma j is the arbitrary point, then this will be your I u minus 1
The
plus t u.
j plus 1 go to this direction, j minus 1 go to this direction, and the line equation will come in the T, and T is having only 3 weights: alpha, minus 2 1 plus alpha, and alpha. So 2 alpha minus 2 1 plus alpha, this will come in the direction in the one line, and alpha I will be having here also, but this alpha being boundary point like this, it goes to the right hand side in that block.
Yes, I understand now.
So what I mean to say is, uh, I have 5 points, and my middle point is the center point is ij. Then my j plus 1 will be the next block, j minus will be the first block, and the current block will be having 3 points. So basically, my matrix will be something like this. Or precisely, if I write my structure of this matrix, if this is understood, then my problem is uh, almost half done. So if I write my structure, then my matrix will be something like, I have uh, my whole structure will be something like this. I have T, I, T, I, then I have I, T here, and in the middle T, I. Just see that, but uh, uh, what I'm saying is that my structure will be T U1 plus U2 equal to, uh, I write here F1 star, which with the contribution from the boundary has come. And as I said to you, my first line will be a boundary. So this whole line goes to right hand side because of the boundary. This line goes to right hand side, and that is known to me. So I have put F1 star. My second block, if I take now along this line, then this is unknown, and this is next term will be also unknown, next line. So my this block will be next will be, because u1 I have written, now I will write for u2, then this will be 2u2 plus I times u1 plus I times u3, and this will be F2, whose first, because my first line or the first equation of this line will have this as the boundary point, it will be going to right hand side. And similarly, in the last equation, this will be at the boundary point. So alpha coming here and alpha coming here, they will be automatically going to the right hand side because being the boundary point. Otherwise, my line will have alpha as given here, alpha minus 2 times 1 plus alpha alpha. So what I mean to say is, my uh, equation for the first, this IU0 go to right hand side because of the boundary condition, and the first alpha and last alpha in the equation also go to right hand side. So my second equation, and then keeping this way, my next equation will be IU2 plus 2U3 plus IU4 is equal to F3, and keep on doing so. Last equation will be by TU, I write M that, plus you will be having IUM minus 1 here, and I will be having FM star, because as I said to you, there are M points along here. So I take the first line, write the equation. I take the second line, I write the equation. Since there are n interior points, each block will have n line or n by n structure. So my T is n by n matrix. U2 is a unknown vector, column vector. I can write I here if you have any problem. And U1 is unknown vector. T is a tridiagonal matrix, which I just wrote on, and I will write again here. But my main problem is that this should be understood, that I will get something like this. This is clear to everybody or not? Hello?
Yes, sir. Yes, sir.
Okay.
Little bit, yeah.
Okay. Because my main contention is that now if I see my T, what is my T? T is a tridiagonal matrix of the form minus 2, 1 plus alpha alpha minus 2 1 plus alpha alpha. This is alpha here. And so I have only mainly this thing, and I have alpha here minus 2 1 plus alpha alpha here. I write alpha here minus 2 1 plus alpha here. So this is my trinomial matrix. Are you getting me or not? Because my theory depends on whole this thing. If you understand this, then rest of the thing you will be understanding. Is it okay or not? No.
So the way you are explaining, it's okay, but definitely,
Okay.
I mean,
So
it needs something like,
I'm
yeah.
coming back because all of you are not from my area, so that's the problem. But I've already written this matrix. Just see that I have 5 points, and I'm considering this is my x-axis. This is my top edge. I go 1 point ahead of it. So this is my top point, that is uh, j plus 1. This is my j minus 1. When I write the equation for this, my equation for this will be equation for ui minus 1j. This is for uij, and this is for ui plus 1j. So when I write, it will be alpha ui minus 1j plus minus 1 plus 2 1 plus alpha uij plus alpha uij. This will be for the current line, whichever current line I am having. I hope you understand. So this is my
Yes, yes,
current line, right? So this
yes.
will be for current line. Now what I'm doing is that I write the equation for the whole system. So when I write the equation, my trinomial matrix, which is current line, will be you will be having alpha minus 2 1 plus alpha alpha for the first point. Any first point you will be having this. But
Right.
when I take this point anywhere, this is the boundary. So this is boundary, this is boundary, this is boundary. So it will go to right hand side. So this alpha will go to leftmost alpha in the first equation goes to right hand side because of being boundary. And same way, last equation has 3 points, but my I plus 1 point will go to boundary because it is a last boundary. This is the last boundary. So the first equation block and the last equation in the block, the first uh, I minus 1 point will go to the right hand side along the boundary, and similarly the last equation will go to the right hand side. So you will have only this triangular structure which I am given here, or I'm given here. They are the same thing. Anybody any
This,
issue?
this capital T is your M cross N matrix.
This capital T is n cross n matrix. You are right, because
Yes, yes, yes.
uh, because my each
Yeah,
line
that I
here
understand. That
n.
this is your trigonal matrix, and this is for each and every point you are finding it. And
So
since the boundary
so
problem होने की वजह से,
हाँ, या जो चीज
yeah,
known है, जो चीज मेरे को known है, it will go to the right hand side.
yes, right hand
So
side.
you
But the
have
only
this.
issue थोड़ा सा जो मुझे ऐसा लग रहा है कि ये movement आप जो ले रहे हो, और you can move anyway, either along x-axis first and then along y-axis, or
No,
y-axis.
no, no, no. You have to have uniform thing, and
Okay,
I will go first x-axis, then I will
okay,
go to the y-axis because I have to move to on. So first I will complete all points along x direction. So मैंने
okay,
पहली लाइन ली और मैंने ये n by n सिस्टम मेरा पहला इक्वेशन बन गया ये.
okay, okay, okay. That is what. Okay, okay.
So I get here I u0 point also, but this being boundary point u0, it go to right hand side. So I write star here.
Okay, okay. Yes, yes. Okay.
Okay,
Okay, now
okay.
it's
So
clear.
I hope this is understood. If this is understood, then my life become easier in the sense that please understand now what I am saying. Because I want to find the solution of this system. My problem is to find the solution of this system. ये system मैंने बनाया. Now, my colleagues who teach it, they use some kind of iterative method or some other method. First thing is that my matrix, total matrix, I say, if I write my total matrix, if you understand my idea, my total matrix A, which is there coming, H of this type, T, I, I, T, I, I, T, I, Ti, that is, this is block tridiagonal system. Block tridiagonal system. I call block because here entries are matrices. So this is the block for the first uh, m equal to 1. This is for m equal to 2. This is for the what you call last equation. And this is, so total there are m block. My matrix order is mn by mn in general, or I have m block each of size n. So I have n by n system m time. So my equations are mn by mn. Now this is a symmetric structure, and my matrix T is also symmetric. Also symmetric. Is it okay, everybody, or not? Because T I wrote here, it is a symmetric matrix. Is it okay?
Yes.
So if this is okay, then since T is a symmetric matrix, my job is to find a fast solution. Now, being a symmetric matrix, I is also symmetric, diagonal matrix, but it is symmetric, I can say. So all of them, all matrices which are involved, them are symmetric, so they have real eigenvalues. Real eigenvalues. So friend, what I am discussing is something called uh, uh, Hockney method. And what I am doing is that since T is a symmetric matrix, I can find its eigenvalues and eigenvectors. My eigenvector will be orthogonal to each other, and my eigenvalue will be real. And then I exploit the nature of my eigenvalues and eigenvector. I can solve the system. Just see what I am doing. So I again write the system H. I have already written here. I have already written, but let me write again. So I have my system H TU1 plus U2 equal to F1 star. Then I have U1 plus TU2 U3 equal to FT. And then I have UM minus 1 plus TUM is equal to FM star. This is my system. Now suppose I know the eigenvalues and eigenvector of T, then as you know, if my matrix of eigenvalue is denoted as Q, whose column vectors are the what you call your Q1, Q2, and Qn. Q is a n by n matrix, and Q1 is the first column, Q2 is the second column, and Qn is the last column. They represent the modal matrix or the vectors, the matrix of the eigenvectors. Then Q TQ inverse will be a diagonal matrix, and diagonal are nothing but your eigenvalues of the matrix, right? Now, luckily, things become very easy for us in the sense that when I try to find its eigenvalues and eigenvector, then what I see is that this matrix T is some kind of Toplich matrix. When I say Toplich matrix, those who do in the Fourier transformation or summability, they know well. Toplich means all diagonal elements are same. like my main diagonal is -2 1 plus alpha -2 1 plus alpha -2. So same. Similarly, this diagonal is all alpha alpha. They start 0 0 0. So this matrix is called a top leaf matrix. And this top leaf matrix, I can find the eigenvalues and eigenvector very easily. So please understand, I'm just writing for this case, my matrix TH equal to, if I have a matrix of the form all A, this is all B, my matrix is symmetric, so I'm taking symmetric form. Then my eigenvalues are given by lambda I is given by A plus 2 into B cosine I pi upon n plus 1, and my I is going from 1 to n. These are the real eigenvalues of this matrix. Anybody want to see? I can give you idea how to find that at the end if you have any. Otherwise, see the GD Smith book on the partial differential equation, numerical solution of partial differential equation. So this is my lambda I, and my Qi matrix. So I define my Qij typically, which is nothing but uh, uh, sine Ij pi upon n plus 1, where I is going from 1 to n and j is going from 1 to n. So my Qij matrix, or my Q1, Q2, Q defined here. Friends, see, this is a symmetric matrix because Qij is equal to Qij equal to Qji, and it is a symmetric matrix. What I do is that they are orthogonal vector. I orthonormalize them. Orthonormalize them. What is the meaning? The meaning is that by Qij become, you want to write cap, you can write cap under root. I find their norm between 0 to 2 pi, and you get this edge. So this become ortho. What is meaning? The meaning is that my matrix is symmetric, my matrix is orthogonal. So what I have? Q equal to Q transpose equal to Q inverse. Q equal to Q transpose because of the orthogonality. Because of the symmetry, Q equal to Q transpose, and Q transpose equal to Q inverse because of the orthogonality. And I am normalized. So what I mean to say is that Q square is equal to identity matrix, or Q inverse is Q itself. That's I have written already. So friends, what is happening now? I have three matrices. In general, they can be different. I take another case, then you will understand that. But here, I have identity matrix, which is a symmetric matrix. So it has the same different eigenvalues, but same set of eigenvectors. So eigenvectors remain the same. Eigenvalues will depend on the matrix, and I use them so that my number of elements become less. What I mean to say is, this is my system, and if I multiply this system as follows, I say I multiply this as so I multiply this by Q here and Q into Q here. So there remain identity. So and then Q here and Q here. Now since Q2Q will be a diagonal matrix of the what do you call your diagonal matrix, because of the eigen Q is the eigenvector. So you will have this a diagonal matrix, and this Q U I write another thing. So what you have is, similarly I Q here, then Q T Q square, and then QU3 Q here, Q T, this is Q square here and Q here, Q here. I write, then my system will become something like this. Since I am writing Q, so my first will become D matrix, second will remain D matrix into, I'm sorry, please, just. I write, so my matrix become D QU1 plus, that remains I QU2 QU2 is equal to Q F1 star. My second will be IQU2 plus, I'm sorry, this is I1 DQU2, and this become IQU3 equal to QFT, and so on and so on. So I write last equation will be QUM minus 1, because I is already there, and Q, you will be having D of Q UM is equal to QFM. Yeah, anybody, any issue, please, because this has to be looked into. Hello?
Sir, I get this point, but the thing is, like, can you just summarize? I mean, we are left with capital A, this block tridiagonal matrix, and we want to solve this, right? And
just let me,
then you, yeah,
I understood your point. Let me explain.
Yes.
This is my first block, this is my second block, this is my last block. So I have last means M block. I have M block. Each block contains n by n matrix.
Right.
Now what I'm doing is that I use the property of each block. What my block contains, a matrix T, I is not a problem. Matrix T, they can be different matrices. In this case, they are all same. But in general, they can. I will use another problem, then you will see that. So T, all are symmetric tridiagonal matrix. And symmetric tridiagonal matrix, I have this property that I can find its eigenvalue and I can find its eigenvector. So why not? So what I'm doing basically, this has, my T has 3 diagonal, and the moment I multiply it by its eigenvector, I will be having only diagonal matrix. So 2 diagonal will go away.
Right. Yes.
And when once 2 diagonal go away, my number of elements become less.
Yes.
And so my computation will be less.
Yes, now I get this.
So what I'm doing is that Q is the matrix of the eigenvector. So I multiply Q to Q. Q inverse is Q, please. So I'm not writing Q inverse because Q inverse is Q itself. If you see, I've done this. My Q matrix is such that Q equal to Q transpose equal to Q inverse, because of I have orthonormalized, and everything will be, this matrix is symmetric, so Q equal to Q transpose, and my method says that this matrix will be, this eigenvector will be orthogonal to each other, so Q transpose will be equal to Q inverse, and hence I have a very simple equation that Q equal to Q inverse. So I have this matrix, so I am diagonalized, I multiply Q and so on. So what you have is this kind of structure, and the moment I have this kind of structure, I have this kind of structure where this matrix become T become D because of matrix of diagonal. And you have QU1, so I write QUI equal to VI, new things, and QFI equal to RI for the sake of example. then my system becomes, just see that, dV1 plus QU2. So I write V2 equal to R1. Similarly, V1 plus D V2 plus V3 equal to R2, and keep on doing so. My last but one equation will be Vm minus 2 plus D Vm minus 1 plus Vm equal to Rm minus 1, and last equation will be Vm minus 1 plus D Vm equal to Rm. Yes, please. Anybody any issue about this? So I have new unknowns V1, V2, V3, Vn. They are blocked. Are you getting me or not, or getting confused? Hello?
No, sir, it's clear now.
Yes, sir. Yes, sir.
Yeah, QUI equal to VI. So wherever QUI is occurring, I replace by corresponding unknown VI. So what I have done now, I am writing same kind of structure, which same type of structure which I got earlier, but I have reduced my bands. Earlier this D was T, so that was having three triangular, three diagonal. Now D is only single diagonal. So D is single diagonal, I is single diagonal. Now what happened is that, what is my D like? My D like is, it will be matrix of diagonal which are all different, L and real. So these are my D. D is lambda 1, lambda 2, lambda n. So D here is same matrix, D here is same matrix, and so on. Now what I do is that from each block, these are the M block, from each block I take the first equation first in the each block. So when I take first equation for the each block, what I have something like lambda 1 V1 1 plus V21 is equal to, I write R11, capital R, so R11. This is, I am obtaining, I take the first entry of the first block. So first entry means lambda 1, V1 will be my VI is nothing but small VI1, VI2, VIN1. Please don't get confused. If you have any question, ask me. I will try to explain it so that you can understand what I am saying. Hello?
Yes, sir. Yes, sir. Yes.
So what I'm having is that my first D is diagonal lambda 1, lambda 2, lambda n. My VI is this column vector VI1, VI2, VN1. So I take first equation from here, because there are n equation here. So I take the very first equation from here, and when I take very first equation, it will be lambda 1 V11 plus V21 equal to R11. Anybody any issue, please? If you understand this, then when I write second equation, then second equation will be coming from the second block first equation, and first equation means will be V1, first equation will be V11, then first equation same eigenvalue. So V my 21 plus you have V31 is equal to R21. Keep on doing so. My last equation will be Vm minus 1 plus lambda 1 Vm1 equal to Rm1. आपको मेरी बात समझ में आ रही है नहीं?
यस सर, मगर ये आपने सर सबकी फर्स्ट इक्वेशंस ली है, फर्स्ट इक्वेशन
बिल्कुल ठीक है, बिल्कुल, because I want a particular structure.
Then in that case, we have similar kind of, this is like
this
one
is
block.
Another triangular matrix. This is triangular structure.
Okay.
So
Okay.
I have something like T1 V equal to R, where T1H a tridimensional matrix. I hope.
Yes.
So I have a tridimensional matrix solved by Thomas algorithm.
Okay.
And when I solve by Thomas algorithm, I get my V11 V, the पहले ब्लॉक की जितनी भी अननोन है वो सब मेरे को मिल जाएंगे. सो आई विल गेट
Okay.
V11 V21 V31 पहले ब्लॉक के नहीं ईच ब्लॉक के पहले अननोन है वो सब मिल जाएंगे मेरे को.
That means कि आप ये कहना चाहते हो कि मतलब बैकवर्ड स्टेप्स लेकर you will able to get that original problem solved. अभी आप यहाँ से सारे V11
नहीं अभी मैं आपने काफी सही समझाया, but let me do. Then
Okay.
when I take second equation, then I will be getting T2 matrix. वो T2 matrix में क्या होगा कि मेरी
Lambda
eigenvalue
2.
lambda 2, very good, very
Yes,
good.
yes,
So
yes,
this will be lambda 2, and
yes.
this will be what you call 2 1, this 3 1, 2 sorry, this is 2 1, no 2 equation 1 2, and this
1 2.
will be, yeah. So this is 1 sorry 2 3 2 2 and so on. Please understand that way. No,
Yes, yes.
1 3, this is 1 3 and so on. So you understand. So what is my T2? My T2 will be only T2 will be changing and right hand side will be changing.
Same.
And
Yeah.
so my T2 will be now lambda 2 1 1. I may get, yeah. Then
Again, this is a tridiagonal matrix with lambda 2
yeah.
as
So with lambda 2, so same
yeah.
routine, you can find a second equation, and my last equation will be Tm, which has lambda m m 1 1 1 1 1 1. This is my last equation for mth block. तो मैंने क्या किया कि each block के first equation का solution निकाला, and I get V1 V11 V21 V31 V41 Vm1. Then
Okay.
I go to the second equation. So what I'm getting, V12 V22 V23 over V32 and so on, and Vm2. Then when
Yes.
I third, so I am getting all V's, but one by one. So I'm getting
Yes.
all V. So all V will be known to me. What is the meaning? The meaning is that I have known now what are my V1, what is these
V2.
all V2, and my
Vm.
Vm. There are M
Right.
M block.
Right.
And what is my V? My Vi is equal to QUI. Right?
Yes.
So
Right.
what is right? So then what is my original solution? My QUI will be nothing but because Q
inverse of Vi.
so
Yeah, and Q inverse is same as Q.
so you get
It is.
QVI. So that is what, and this is done for each UI. So that is the strategy. What is the strategy? Please understand now. If I should appreciate.
I understand the strategy, but the only issue जो मेरे दिमाग में आ रहा है सर कि आपने यहाँ पे थॉमस एल्गोरिथम से दो हमें थॉमस एल्गोरिथम का डेप्थ नहीं पता अभी, but you use थॉमस एल्गोरिथम to solve this final problem, that final equation TV is equals to R if your T is tridiagonal matrix.
Okay. I come to
But
that.
मैं आपसे एक सवाल पूछना चाहती थी कि जो इनिशियली आपने जो प्रॉब्लम बिल्टअप की थी तो वो ट्राइडायगोनल नहीं थी, मतलब आई थिंक दैट वाज ब्लॉक ट्राइडायगोनल, दैट इज व्हाई
Yeah. Okay. Let me summarize. Summarize.
बस हाँ, I need just a little bit of summary of this. Yeah.
Let me summarize. What is the problem? The problem before me is that I am given a system AU is equal to F, where my U is M by N block, M n unknown, where first block has N unknown, second block has second from second block, and so on. So if I write my U as IJ, then if I write U12, इसका मतलब है कि पहले ब्लॉक का दूसरी एंट्री. If I write U23, meaning is that second block की third entry and so
third
on.
entry.
So my U is Uij and similarly F is Fij. So I have block wise entries, and A is my this matrix. Now,
Mhm.
I want to exploit the structure of the matrix A.
You
What is
simplify the structure of capital A, that means you
yeah,
reduce the.
yeah. Because here I have 3 diagonal mainly. Here is 1 diagonal. So total I have 5 diagonal. And so
Mhm.
if I use this 5 diagonal, all the computations are to be done on the 5 diagonal. So what I have done is that by taking the eigenvalues and eigenvector, the T matrix is reduced to diagonal matrix.
Okay.
That
Yes,
I
but sir, I just need a favor in that way कि ये theory था, but मुझे लगता है कि it must be supported by some example. If you can just give us, if you can solve it in a class, or if you can just give us some little bit a small example with the help of the PD,
no, okay,
any
no problem. No,
wave
no,
equation maybe,
no,
or
no, no, not
different.
this is elliptical equation. Please
Okay, this is
don't.
elliptical.
Yeah, this is Poisson equation, elliptic equation.
Okay, Poisson's equation.
Yeah,
So it will be really great. I mean, it will help us to
no problem,
understand this.
no problem. Let me give you the
Yeah.
example. So,
Yeah.
yes, please. अब कल ले जाना यार, मैं लेक्चर ले रहा हूँ. ले जाओ इनको, ले जाओ, चलो उठा के ले जाओ. मेरे कोई कागज रखो तो दे देना मुझको. Okay, please, I take the example. No problem, I get your thing. Example. So what is the example? I take the equation h day to u by day x2 plus day to u by day y2 equal to -1. I want to make my life easy. Uh, and I have a square thing where I divide into uh, 2 interior points. I have this problem. And u equal to 0 on the boundary. I hope everybody understand what the problem is or any issue.
No issue. One just doubt. This triangular, the choice of these M and N points depends on us.
Yeah, depends on us how we choose H1 and H2.
Okay. And I think the solution will be more the more जैसे कहते हैं accurate if we take more and more points. Is that so?
Yeah, true. That theory is there. The
Yeah.
H1, H2 goes to 0, your solution become exact solution.
Okay.
Okay.
Yes. It's
Okay.
clear.
So to make things, I take my H1 equal to H2 equal to H, which is in this case, as you can understand, 1 by 3, because my square is 0 to 1, 0 to 1. I hope everybody is understanding what I'm saying. So I have this matrix. I call this point as 1, this called as 2, I call this called 3, I call this 4. Rest are boundary condition I have suitably chosen as 0, so it doesn't affect me. Right. Now, if I use the first line, then my H1 equal to H2 is equal to H. Please understand this 2 minus alpha minus 2 1 minus alpha, it become -4. This minus,
Yes.
so alpha is 1 because H1 upon H2 is same thing, so it become 1, so this is become 4, -4. So if I write my equation for the first line, I have 0 point here, and for the sake of example, I'm not calling 3, so I call this point as 5 without any problem. So my first line will be having the first equation H. Uh, I have this is the 0 point, so I write u naught minus 4 u1 plus u2, because the alpha is 1 minus 2 1 plus alpha is -4 plus u2. Then my point ahead here is u3, and this point which I call 6 point, let's say, plus u6 is equal to h square, which 1 by 3, so 1 by 9 minus 1, so minus 1 by 9, minus 1 by 9. Anybody any issue?
Sir, just a second. Yeah, you have taken along this line. Definitely because the below line is the boundary line, everything is zero here. So we started with the first line. So this is your u0 minus 4u1 plus u2 प्लस u3 एंड u6 ओके ऊपर एंड बट ये जो पॉइंट का सिलेक्शन आप रैंडमली ले रहे हो
ना
इज इट
रैंडमली
नॉट
ले रहा
गोइंग टू
मैं
बी
पहला नहीं ये नंबर तो मैंने दिए वो
हाँ
इसलिए
मतलब
क्या
मैं एक्चुअली यही पूछना चाह रही थी कि ये जो नंबर आप नंबरिंग दे रहे हो
ना
वो इज इट गोइंग टू क्रिएट
चलिए
एनी
मैं
कंफ्यूजन
नहीं नहीं आपको कंफ्यूजन हो रहा है तो मैं उस तरह से लिख देता हूँ वो मेरे लिए भी अच्छा है फिर क्योंकि
ओके ओके
दैट्स द वे सो
बिकॉज
दिस
यू आर एन एक्सपर्ट डेफिनेटली यू कैन हैंडल दिस
I know yeah
कंफ्यूजन
that is
या
this is my one point this is my
या
1 2 point
1 2 पॉइंट
this is my 1 3 point this is
राइट
my
राइट
1 0 point
1
ठीक है
0 थैंक यू
हाँ,
सो मच या
this is my 2 1 point this is my 2 2 point this is my 2 3 point and this is my 2 0 point I hope
राइट
everybody
राइट
right and this
नो
is my 0 1 point this is my 0 2 point this is 0 0 this is 0 3 I hope everybody understand this is 3 0 3 1 3 2 3 3 any issue please so I write
नॉट एट
that
ऑल सर नॉट एट ऑल थैंक यू
so I have my equation H u10 minus 4 u11 I 4 write this way because u and should not get confused 4u11 plus u12 this is from this line then 0 1 point from this point and
यस
2 1 point from the up is equal to 1 upon 9 minus 1 upon 9 any issue
नो सर नो
now what happens is that my u10 will be 0 because of the boundary everybody understand that or not
बिल्कुल सर बिल्कुल
and u01 is 0 because
ऑल्सो
of
बाउंड्री
boundary
यस
so my first equation will be minus 4 u11 plus u12 plus u21 is equal to minus
1
1
upon 9
1 upon 9 right
yeah
now I go
now
to the second point so my
similarly
second
you
point
can do yeah
second point will be if if you allow me to then I can write my second equation here then I copy there so u12 this I get 4 4 u12 and I will be getting u11 and this will be going to 0 because the boundary point and this will be going to 0 and I will have only u22 is equal to minus 1 upon 9
yes
anybody
sir
right so
yes sir
this is my second point I write here so because the figure is here now same way I write my equation for 2 1 my equation for 2 1 will be minus 4 u21 from here plus u11 from here and u31 will be 0 so I will be having plus u22 equal
yes sir
to minus 1 by 9
right sir right
right so
right sir
and if I write for u22 so I write for u22 here then this will be minus 4 u22 u12 and
then
this
the
is
other parts are 0 yeah
0 and I have my u21 point for this and this is equal to minus 1 by 9 anybody any issue
no sir not at all
now just see that I have 4 unknown 1 1 1 2 2 1 2 2
2 2
and 4 equation I have written
yes
right now let me write my equation in the form of blocks so I hope you will get me I have only this 2 by 2 system my first equation block will be u11 and u12 my second block will be u21 and u22 right everyone
yes sir
Now I know that this is coming 1 1 here, which I have already told you. Otherwise, also the coefficient of what you call u12 is 1. So this is 1 here. This equation. So u21. This equation u21. Yeah, I'm here. I'm sorry. Yeah, this is the equation for this. So
Ah,
right. So
yes.
so I have
Minus
minus
4 minus 4 0, I think. No, 1.
1 1 and 1 minus 4, only two equations. So minus 4 1, 1 minus 4, because 2 by 2 matrix. This is a tridiagonal matrix. I have not have one middle line because of I have not taken 3 point. So
Yes.
minus 4 1, 1 minus 4 1 1, u1 1, u1 2. This is my first block. First line, and this is for the second line. I have written for second line 2 minus 4 u21 plus u11 u22. So this will be structure for the first line. Now if I go to the second, uh, yes please, if you have any issue, tell me.
Yes. No issue, sir. It's
Okay.
clear. It's very much clear.
So I take now this line. So when I take this line, my u11 comes from here.
Again, 1, 1,
and then minus 4 1
4,
and minus 4
1 minus 4.
this is, and this is my first line here is minus 1 by 9 minus 1 by 9, similarly minus 1 by 9 minus 1 by 9.
In that way, matlab, we will get this arrangements of the blocks for each line
So
in this manner of.
basically I've taken simple case. If I take
Yes,
three
yes.
lines, then I will be getting 1 4 1 here, 1
Yeah,
here,
we should be more careful in that way. Yeah, yeah.
1, and I get 1 minus 4 1 here, and you get
Okay.
more element here. So you have 1 3 here, you have u2 3 here, and so on and so on.
Right.
Right. So what is the thing? My only thing is that I'm not using any other issues. I convert this matrix into its diagonal form.
But sorry to interrupt you. If we like, suppose you have taken here three mn and both are equal to
Yeah,
get the square kind of matrix.
I have taken a square. I've said
But
this
is this a possibility to take? I mean, will that calculations be on a similar way
yes,
if you take mn and different?
Let me remove that anxiety of yours. So I take a rectangle. I take 2 lines here and 3 lines here.
Okay.
Right. So what happens? I have 2 blocks because my bidirectional have 2 things, and each of 3 by 3.
Right.
So that is not issue. Only issue is that, so I have 3 interior points. So 3 by 3 block, I will be having 2 blocks, nothing else.
Okay. I understand. Okay.
If you have any issue, then I will come to know about.
No.
Okay.
So thank you.
Okay.
Yeah.
So what happens now? What I'm doing that by multiplying by q, I'm just saying that you can write this block H, lambda 1, lambda 2, lambda 3. I've taken 3 by 3 in that case. This will remain 1 1 1. This will remain 1 1 1, and this becomes lambda 1, lambda 2, lambda 3, and you will have this H V11, V12, V13, and you have V21, V22, V23, 23, and your right hand side becomes now q times. So I multiplied by q, and I will be having this something already known to me by multiplying by q. So this is minus 1 by 9. Here is minus.
So you get these, obviously the mid steps you have just taken for granted in a way that we understand, or definitely we understand this block capital T here. You take this all this calculation and get this Q, right?
No, I write q to q, and q is carrier identity. So QU1 is equal to, I write QU1 as V1, nothing else. I write Q is carrier.
No, that is what I'm saying, that these eigenvalues, lambda 1, when we actually solve these, then we get these lambda 1, lambda 2, lambda 3 as known ones, right?
No, I know the formula. I know the formula. And anybody has any doubt, I will solve that problem. I will give you outline how to find that.
Okay,
That's
okay,
no,
yeah, this is the formula. Oh,
yeah,
right, right, right.
yeah. I
Very
have
nice.
given this formula, and this given I have given the eigenvectors also. I hope.
Okay. Yes, yes, yes. Very clear, very clear.
Okay. So what I've done, sorry, what I've done is that uh, I got this system. Now, since I want to solve systematically, तो पहला इक्वेशन मैंने इसका लिया. तो
Yes, sir, बिल्कुल.
what I get is lambda 1 b11 plus b12 is equal to right hand side, which I call r11. Then पहला इक्वेशन इसका लिया. तो I get, as you understand, इसका लूँगा तो this will multiplied here and this will multiply here. So v11 plus lambda 1 v12 is equal to from here, so r21. अब मतलब ये टाइडल मैट्रिक्स बनेगी
सर
यहाँ
ये
पे.
नीचे वाला V21 बनेगा शायद.
आई एम सॉरी v21. आई एम सॉरी
Yes, yes.
v21. Right?
Okay, you मतलब just pairing these जो lambda ones की जितनी भी equations है, you are pairing them and you get this.
Yeah.
set.
So, and then this can easily be solved by Thomas algorithm.
Solved.
And Thomas is not a big issue because I want to do something more. But if you have any issue, I will resolve that issue too. Because I'm sorry, because my time is less, but I try to do something. So I hope you
No.
understand.
Yeah, we understand it very well. Theory part आपने बहुत
If you
अच्छे से
want.
समझाया सर.
नहीं आपको
मैं सिर्फ इसका मतलब because the computations this is a small example you have taken, but I'm sure this computation numerical part is there any algorithm for MATLAB something like this or you make the whole code for
देखिए ये तो आपकी चॉइस है, पर मैं सबकी एल्गोरिथम देने को तैयार हूँ आपको. मैं थॉमस एल्गोरिथम एक्सप्लेन करने को तैयार हूँ. मैं आपके आइगन वैल्यूज कैसे निकले हैं उसको तैयार हूँ बताने के लिए. आइगन वेक्टर का एक अलग फॉर्मूला है, पर आइगन वैल्यू कैसे आई है उसको बताने को तैयार हूँ मैं आपको.
थैंक यू सो मच सर. या थैंक यू. अगर आप थॉमस यहाँ पर अगर आप ले सकते हैं तो
no problem. I will not do anything cylindrical case, but let me do this problem for you.
Yes.
And this is for all the students, all the my participant, because keep in mind, because this system you get time and again in numerical analysis. This runs for all. So suppose I have n by n tridiagonal matrix. I take tridiagonal matrix. I'm not bothering about anything else. So this is bn minus 1. This is c2 cn, and I have x1 x2 and xn equal to r1 r2 rn. Right? This is my simple tridiagonal system. Anybody any issue about it? Because tridiagonal, right?
Yes.
पहली चीज when I want to store, I will store three things. What is three things? I call them at array A, which has A1, A2, AN. I have another array B, which has, so this is array which has B1, B2, Bn minus 1. But I give n, last one is not a problem. And similarly, C, which has C1, C2, Cn. So I maximum storage is only 3n. I hope you understand. And I have the right hand side, which I say Rn. So you have only 4 array, A, B, C, R.
Okay.
Now I apply Gauss elimination method.
One small doubt, sir. जो ये आपने A is a diagonal kind of, so it will go n arrays definitely. But do the above array, the B diagonally and
Madam, B will be having one less element, so there is no issue.
Okay.
Because as you go away from main diagonal, the size of the diagonal becomes smaller and smaller.
हाँ, मैं वही आपसे बोल रही थी कि क्या ये कैपिटल बी में जो आपकी लेंथ
मैंने
ऑफ द
n ले
एरे है,
लिया, मैंने n ले लिया, और
तो एक
आपके
का
पास
जीरो।
bn को मैं यूज नहीं करूंगा, एंड
ओके ओके ओके,
c1 को मैं यूज नहीं करूंगा।
नहीं करूंगा।
हाँ, नहीं
ओके
करूंगा, मैं प्रोग्राम लिखूंगा तब नहीं लिखूंगा, मैं आपको अभी बता रहा हूँ।
ठीक है
And
सर,
you
ठीक है।
will understand that. You will understand.
ओके
Those who knows the little bit of program understand. Gauss elimination method. Basically, Thomas is nothing but Gauss elimination. There is
ओके
certain observation which you have to make. Now, please understand from me. When I make my subdiagonal, which is C element, as 0, that is what I have to do in the Thomas algorithm, because the below diagonal elements are C2, Cn, only one diagonal. So I have to make C2 0, I have to make C3 0, I have to make Cn 0. Right?
यस राइट।
Now, what is the meaning? The meaning is that, please understand, if I come to ith, apply my thing, then I have ai star xi plus bi plus 1 xi plus 1 is equal to ri plus 1 star. This is my ith row, because when I make my below diagonal 0, below subdiagonal 0, then only my diagonal element A2 will be changed by B1. जब मैं C2 को बनाऊंगा 0, तो केवल मेरा A2 चेंज होगा, बाकी सब 0 एलिमेंट है, उससे B2 पे कोई फर्क नहीं पड़ेगा, क्योंकि उसके ऊपर 0 है। ये बात समझ में आ रही नहीं आ रही आपको?
हाँ सर, समझ तो आ रही है।
अरे
ठीक
what
है।
I will do, I divide by A1 multiplied by C2, so that my C2 element becomes 0. That's what I do. And when I do so, my A2 will be becoming, let me write. So divide for second row, divide by A1 and multiply by C2, so that I call this as ratio as C2 upon A1.
Okay.
And then my A2 become the previous A2 minus
A2 by A1.
Ratio, I not write
Ratio. Yeah.
ratio multiplied by B1. This is my A2. And what is my R2? My R2 will be R2 minus ratio into R1. And anybody, any issue, please? जब मैं सेकेंड एलिमेंट को 0 बनाऊंगा, इसको 0 बनाऊंगा, तो ये से A2 तो चेंज होगा, केवल A2 के ऊपर B1 है, B2 के ऊपर तो 0, और सो ये मेरे को मिलेगा। अब मैंने जैसा A2 को बताया, तो ये तो 0 हो गया। So what I say is that I defined something called ratio, which is nothing but Ci plus 1 divided by AI.
Yes.
And then my AI plus 1 will be nothing but AI plus 1 minus ratio, Ci plus 1 I am writing. So ratio into what you call ऊपर का element BI. Right? Anybody?
Yes,
and similarly, my Ri plus 1 is equal to Ri plus 1, क्योंकि R2 से घटेगा वो, Ri plus 1 minus ratio into what you call your Ri.
That means ultimately you are just transforming this into
upper triangular form.
Upper triangular
form.
Yes.
Right? So yes. So this is what Thomas says. Once I do this, what will happen? What will happen is that I will be getting my A1, this become A2 star, change हो जाएगा, this become AN star, ये भी change होगा, क्योंकि my I is going from, because I'm writing I plus 1 to N minus 1. Right? And this B will be not changing at all. Please observe that, because I'm nowhere B2 is the upper element is 0. जैसे ही मैं यहाँ जाऊंगा तो ये B3 हो जाएगा उसका, तो ये एलिमेंट 0 है, यहाँ पे ये एलिमेंट 0 है, so
Yes, yes,
so
yes,
B,
yes,
B will not be changing, B remains same, and
yes, yes.
and I get R1 R2 star Rn star. अब क्या करना है, बस बैक सब्स्टिट्यूशन करो। बैक सब्स्टिट्यूशन में क्या करना है आपको, एक लाइन में दो इक्वेशन है। सो आई फर्स्ट आई गेट माय लास्ट सॉल्यूशन xn which is nothing but Rn upon star upon an star. I hope you understand, everybody understand that.
Yes, sir. Yes, sir.
So
Very
मेरे को
much
एक्शन मिल
fair.
गया। अब क्या है कि bn-1 को xn से मल्टीप्लाई कर दूंगा, राइट हैंड साइड में ले जाऊंगा, और an-1 से डिवाइड कर दूंगा, तो मेरे को xn माइनस only one element you have to take to right hand side, because upper triangle has only one element.
Yes, yes, definitely. Upper triangular matrix is easy to solve. It's all, yeah.
Yeah, easy to solve, but in this case upper triangular
Yeah,
is
so
having
we have to be bit yeah, yeah, definitely.
दो एलिमेंट है ना,
हाँ, दो एलिमेंट हैं।
तो एक ही एलिमेंट तो ऑफ डायगोनल से तो डिवाइड करना है, ऑफ डायगोनल से ले जाना है, so I will take off diagonal element to right hand side, divide by an-1, you get your xn-1, take that multiplied by xn-1 to bn-2, take to right hand side, divide by an-2, you will get x2 and so xn-2 and so on. So by back substitution you get your solution. So this is what Thomas says, and the only thing is that Thomas is popular because the way you are doing computation.
Yes, sir. Yes, sir.
Very less computation, only two array here, two things here, back substitution, nothing else. So there is less contribution, less thing. Yeah, any other thing?
Sir, just one request to even because most of the students, even I, though eagerly seeking for the notes, definitely. And if we even get this recording of this, I request organizers to please arrange the recordings of each session. Thank you so much, sir. It's really nice. You explained very well.
Let me complete my.
We can even try, if you have time. We can start with cylindrical.
Yeah, that's what I do. I give you main idea, and please get the idea. And if when you should tell me. Now I told cylindrical. Poincare equation. So my first equation is I will give you main idea. Plus 1 upon r du by dr plus du by dz2 equal to frz. This is axisymmetric Poincare equation. What I mean by this is that I have a cylinder of height h. This is my x-edge. Now, since equation is independent of theta, so theta is not important. What is the meaning? Meaning is that if I find the solution in along one theta, then if I take another theta, same solution will be valid. Are you getting my point or not? So suppose my from R1 to R2 and my Z is from H1 to H2. Without loss of generality, I can take this as 0. That is, I have something like this. There are two cylinders having same x-edge, having the same x-edge. So this is my thing. This is the first domain. Other domain could be my this is 0, and I have some capital R's, this kind of thing. Then my Z is some something which is having height, so 0 to h, without any problem. Now please, those my friend, young friends, please pay attention to me. This domain is much easier for me to solve. I say much easier in the sense that the theory which I applied for rectangle, same theory I can apply, only my matrix will be changing, but eigenvalues will be by the same formula. And so since matrices are same, so eigenvalue will be changed, and my eigenvectors will be the same. This problem a bit problematic, which you should understand, those who know mathematics, that r equal to 0 create problem, because if I take this kind of domain full circle, then this is the problematic thing. Because r equal to 0, 1 upon r cannot be defined. It's some kind of singularity. But my problem is axisymmetric, so my agential condition at r equal to 0 is du by dr equal to 0. It ought to be that at r equal to 0, then it will give you du by dr equal to 0. If you see some of the presentation, when such this equation arises, I normally ask this question because people don't know. So this is one of the conditions you have to have. And then there are number of ways I can tackle this problem, but the best way I tackle is that since r equal to 0, du by dr equal to 0, so I will have equation at r equal to 0 h d2u by, my goodness, I write here, I will have du by dr2 plus 2 d2u by dr2 plus d2u by dj2 equal to 0. This is for r equal to 0, because this condition I apply the hospital rule, and sorry, this is this become, so this become 2 of this will go off. So by this equation I apply hospital rule here, so this become 1, this become d2 by dr2, this d2 by dr2 and combine together. So r equal to 0, I have this equation, and when r is not equal to 0, I will be having this equation. I hope everybody understand that.
Yes, sir. Yes, sir.
So if I want to solve in the not hollow cylinder but full cylinder, then I have to use this equation, otherwise this. Now please understand, because of the axisymmetry, if I take my one cross section, then my one cross section will be something like this. सिलेंडर को मैंने मतलब इसको सिलेंडर में से अपने इस एक्सिस से मैंने इसको रोटेट कर दूं तो मेरे को सिलेंडर मिल जाएगा. So my
Right.
my cross
You
section
take a vertical section of this.
Yeah.
Vertical.
Right. You are. So basically, I am solving my cylindrical equation in a rectangle. That is what
Yes.
So I will be
yeah, we were confusing that आप वो गोल को कैसे लोगे? Yes. Okay.
I am coming that also. I will, if you permit me, then I will take that also, no problem. So this is my what do you call grid or mesh choosing the point. I take H1 along what do you call Z direction. Sorry, R direction. This is R direction.
R direction.
And H2 along Z direction.
Z direction.
Right. Then if I solve my equation, then my Uij is nothing but Uri Zj, which is nothing but if you permit me, I H1 plus JH2, where my base is 0 and my center is at 0. This. So my equation will be for this equation will be Ui plus 1j minus 2Uij
plus
U upon
J,
this is
F,
H1 square.
F1 square. Right.
ठीक है, plus 1 upon Ri, because my equation is Ri, and please, I'm at the moment I am not bothering about 0. So my 0 is not a part of thing. Ui plus 1j minus ui minus 1j. This is for du by dr of second order 2h1 plus uij plus this is jz2 minus 2uij plus uij minus 1 upon h2 square equal to fij. Yeah, anybody, any issue, please?
No issue, sir.
Right. Now, what I do is that I denote my PIH because this coming here. So my PIH, what do you call 1 upon RIH1. So if I write PIH 1 upon RIH1, then this equation, if I write here, then this equation will become, just see that, this is uij plus 1, and so ui plus 1, ui plus 1, j, both are same. So I will be getting plus sign. So 1 plus pi ui plus 1j. This is this equation minus, I multiply by h1 square so that my life become easier. So I write here h1 square also. So this become h1 upon ri, and this become alpha h h1 square upon h2 square, and h1 square fij comes here. So I write pih h1 upon ri. I hope you understand, because h1 square I multiplied. So
Yes.
so this is.
So, but then in that case, we have the here. Okay, fine.
Minus 2, 1 plus alpha, which is there, uij plus 1 minus pi ui minus 1j plus alpha uij plus 1 plus alpha
uij minus 1.
Right, everyone? Is equal to h1 square fij.
Yes.
Now, please understand me. Very good. The questions you asked in the beginning. Along this line, my R is fixed. 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 Here is R0, here is R1, here is R2, here is Rn, and this is my Rn plus 1. I hope you understand me.
Yes.
So, because I want same diagonal, I will solve this equation. There I took x-axis first, or horizontal parts first. Now I am going along this direction because I want my diagonal to be same. So I will go from here to here, then here, first here to here, then here to here, and so on.
Okay.
And if I do so, then my matrix will be something like this. If I write matrix, so please let me write the system, then you will understand what I'm saying. So I will be having T1 here and D here. Then D, you will understand everything. D
yes,
here,
yes.
And D, dm minus 1.
And D here.
And D, Tm here.
Tm, right.
And you have the blocks, unknowns, and right-hand side. It's according to, right? What is my Ti? My Ti will be the
ऊपर की तरफ जा रहे हो आप ना? हाँ, okay.
So my Ti will be, if I see my Ti, then I go upward, and so I will be having, I keep I fixed. That's the meaning. I don't keep J fixed now. So I will be having my matrix will be alpha minus 2, 1 minus alpha. This will be my T.
Right.
So,
right.
So this is D1, this is D2, This is dm minus 1. Please let me write. This is d2 star. D1 star will be going to right hand side. D2 star, and this is dm star. So all diagonal elements are different. So my Ti will be something like 2 1 plus alpha 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 minus 2 1 plus alpha 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 minus 2 1 plus alpha alpha. This is my T because I have taken vertical direction. So alpha alpha and minus 2 1 plus alpha. Anybody any issue, please?
No issue, sir.
Okay, and then my D will be I plus 1. So my D matrix will be
1 plus I.
Di equal to 1 plus Pi. 1 plus
Sorry,
Pi.
1 plus Pi
1 plus
and
1 plus
plus
Pi. This is my D1. And my what is my D2? D1 is I said Di star. This is Di, please. And Di star, it will be 1 minus Pi. 1 minus Pi. Now,
Right.
friends, all are symmetric matrices.
Yes.
That is what I desired. That's what I desired. So all are
Yes.
symmetric matrices. My eigenvalues are known. My eigenvectors are known.
Unknown.
And if you want to solve it, you can solve now by Hockney method. The way I have solved the another rectangular problem. Same way I
Yes.
solved this. Indeed, we have published the papers in 90s, published and well received in the sense citations are there. So what I mean to say is, this is the case when I take that case. So please understand my idea. And if I want to solve in the complete square, then first equation will be coming from this equation only. That's the only difference.
Okay.
And you can again form the system and solve it. Now I come to, if you have patience and listening to me, then I will continue for the polar coordinates. Otherwise, I will take questions from you and answer that. If you have patience, then I will go for that. You can ask the participant.
Yeah.
I will.
One thing which I'm just curious to know that definitely Cartesian is a less time consuming. वैसे तो this is we always encourage to change the systems in a way of getting cylindrical or polar coordinates में, but यहाँ पर cylindrical coordinates में problem Poisson को करना is more time consuming, isn't it? Or what do you suggest? मतलब ये एक सवाल मेरे दिमाग में आ रहा है.
देखिए मैं आपको डिफरेंस बताऊं. If I go to rectangular Cartesian coordinate, my matrices are very easy matrices.
Yes, yes.
And so it will take less time.
Yes.
Now I go to the axisymmetric problem. Then I have m plus 2m, I mean to say 3m different matrices, in the sense that my di are different, my t1, t2, tm are different. Are you getting me or not?
Okay.
So these matrices, these are m matrices. They are all different. Their
Yes.
eigenvalue will be different. No, ti, this is not different. I'm sorry. This is t, but my
This is same, right?
my di and di stars are different.
Yes, yes.
So that is the difference I'm getting. So according to it, since things are changing, so you have more slightly more computation that way, but structure remain the same.
Yes, definitely structure will remain same. उसमें तो कोई दुराही नहीं है. मैं सिर्फ इतना जानना चाहती कि सर कि सजेशन आप क्या दोगे, मतलब किससे सॉल्व करें अगर कोई प्रेजेंट कोई प्रॉब्लम हमें पॉइजन दी गई है तो, एंड वी आर इंडिपेंडेंट, या ये भी कुछ डिपेंड करता है बाउंड्रीज पर या फिर
नहीं बाउंड्री पर नहीं डिपेंड करता.
जनरली जैसे आई टीच मल्टी वेरिएबल तो ये सजेशन दिया जाता है बच्चों के कि हम क्यों वेरिएबल दूसरे स्पेस में जा रहे हैं, व्हाई वी आर ट्रांसफॉर्मिंग दिस, बिकॉज इट मेक्स थिंग्स सिंपलर और लाइक इंटीग्रेशन इट मेक्स integration part
It
easy.
is.
But why
I just tell you,
Poisson?
Poisson equation, if you do in the Cartesian coordinate of the cylindrical problem, you have many problems.
Okay.
Because Poisson equation in cylindrical coordinates will make life much easy. And the way I have suggested, only difference could be कि मेरा ये सिस्टम बनेगा, वो चाहे मेरा हो चाहे कोई और हो, सबका यही
Okay.
सिस्टम। इस प्रॉब्लम को जो सिस्टम ऑफ लीनियर इक्वेशन है, हाउ यू सॉल्व, दैट रिमेन द चॉइस ऑफ द पर्सन। एक क्या
Okay.
करेगा, एक क्या करेगा, मैटलैब को यूज करके तुरंत सॉल्यूशन निकाल लेगा।
Right.
ही इज हैप्पी, बट ही डजंट अंडरस्टैंड द प्रॉब्लम,
Yes, sure.
राइट? What I have done is that I understood the problem and then I exploit its property and I say I apply my method, and bet me my method will be giving you much lesser time solution. My CPU time will be less than MATLAB.
Okay.
That's what I say. Because
Okay.
because my computation will be lesser. I am doing mathematics, that is there. So my
Yeah.
mathematics time is there, but my computer time will be less.
Less. Sure, sir. Sure. Thank you, sir. Thank you.
If you have the question, otherwise just I just give you idea how to do.
No question, sir. Thank you.
So I'll let me take that kind of problem also, so that people will understand what I have. And I have published all paper about this. 1 upon r du by dr plus 1 upon r square du by d theta t is equal to fr theta. This is the problem. Now this problem, I have this kind of thing. I hope you understand, something like this. Please never mind my figure, but these are the arc, and you have radius. So this is some angle phi1, this is phi2, and this is r1, this is r2. I hope everybody understand that what kind of cylindrical problem. I have cylinder here, and some center here, and so my angle phi1, this is theta1, theta2, and my radius from. So this is the problem defined here. R1, this is R1, this is R1, this is R2. Now what I do is if I discretize it, so there is no problem. I will discretize same way. I take delta theta. So my delta theta will be this along arc. So this is my delta theta, and this is my some h along r direction. So I have step length delta theta along theta, and this is h along r. And I can replace this. Only thing is that you have two kind of problem here. The problem is that your phi theta 1 and theta 2 are different and none of them is 0. If I have something like theta 1 is 0 and theta 2 is 2 pi, or I have full circle like thing, I can have something like this in annulus region, or I can have full circle only. Matlab, my theta going 0 to pi and r is 0. Here r is going from r1 to r2. So this is my annulus region. This is my full circle. So r, and you have something like this where your phi 1 and phi 2. Now I just tell you the problems which are coming. This region is if you apply finite difference thing, this is not problematic. Only thing is that what kind of matrix you will get different. This is a problematic in the sense that r equal to 0 part of this, and this is not a problematic. This is something like what I have already done in rectangle. Only thing is that concept is changing. So I take delta theta here, delta theta here. So this is one region, or I divide further. So you have a delta theta, and your more points will be coming. You take the approximation. This give you matrix where you choose wisely. same kind of structure which you are having earlier. I say structure, their values will be different, but it will not create any problem because it will be something like rectangle where arc is changed by r delta theta. R delta theta, that's the only difference. If you take this structure or this structure, I take this, then please understand now my T matrix is no longer tridiagonal. It becomes circulant. It becomes circulant because when I take my delta theta, so this point will contain this point as a neighboring point. So this point is a full circle. So what you have is that this will give rise to a matrix something like this. Please understand, circulant matrix minus 2, 1 plus alpha. Alpha, earlier you get some point here, but nothing like before it. If I take this point, before it is this point, which is full circle. So what I mean to say is, this become alpha here. And similarly, if I use here, so this alpha comes here. So this is something like alpha here minus 2, 1 plus alpha. So this is a circulant matrix. Are you getting my point or not? Because periodic nature, you will have circulant matrix. So you have alpha here, alpha here, alpha here, and minus 2 plus 1 plus alpha here. So this is circulant matrix. Hello? Hello?
Yes,
Hello?
sir.
Yes, sir. Yes, sir.
So what I mean to say is, you have circulant matrix, and I have already given one of the lecture that finding eigenvalues and eigenvector of circulant matrix is not very difficult. It's rather easy. One omega square and omega n. It is a symmetric matrix, so real values will come of them, and so eigenvalues and eigenvector can be obtained. Now, what I mean to say is, the structure will be same thing. Your eigenvalue formula and eigenvector formula will be different. If you want, I can give you eigenvalue, eigenvector formula. If you need it, I have with me, or you can see my papers. I come to this structure, which is rather zero part. Then people have different things, but what we have done is that if this angle, this boundary condition is g theta at the boundary, as you understand, it depends on theta at r equal to boundary r equal to r, full circle. In that case, my my boundary, the 0-point solution can be obtained very easily with the help of Poisson integral formula, which you teach in the Poisson integral formula, which you teach in the complex analysis, or otherwise what we call mean value of the thing, and which will be the thing. But so solution at r equal to 0, I write, please. I write here by solution at r equal to 0 will be, I just take 2 minutes. R equal to 0 will be solution at 1 upon 2 pi 0 to integral 0 to 2 pi g theta d theta. You put in the Poisson formula, r equal to 0, unnecessary thing cancel out, and you get only g theta there. And so solution at r equal to 0 is known to me directly from the Poisson formula. That means now this is becoming 1 point, and full circle become another boundary. This 0 is a boundary where solution is already obtained me, so I can apply my theory again. So r equal to 0 will not create any problem, because r equal to 0 solution already obtained by me. I use it as a tip boundary, and solution can be obtained. Only thing is that eigenvalues and eigenvectors formula will be different, nothing else. You can solve in the cylinder 2. All these things are published in 2 papers for Z and polar coordinates, and this is what I need to tell you. I'm sorry if I have taken more time, but I wanted to give something which you can understand. And I know getting ideas of second person or other person is more difficult unless you are in the same line. So whatever possible from my side, I try to explain well as I can. So thank you from my side. Hello.
Thank you, sir.
Thank you very much, sir.
So
Sir,
that's all. If you have any question, please don't hesitate to ask me. In the second lecture, I will be doing numerical solution of finite difference solution of heat conduction equation in 1 and 2 dimension, telling how to use ADI method. If you have any suggestion, you give me beforehand so that I do not prepare in that way.
so any queries from the participant side? I request all the participants to please put your mic on the mute mode. So I express my heartfelt thanks to Professor R.C. Mittal sir for providing your precious time for this session and putting his sincere efforts for the participants of this TEW. And I am very thankful to all the participants, all the distinguished guests, our head of the department, Professor Alka Tripathi ma'am, and all the professors and all the faculty members of our department for attending these sessions. And I request all of you to please join the next session tomorrow with the same link at 3 p.m. And we really hope that you will take the effective output from this lecture, that is based upon the classification of PD and all other concepts which are very well explained by the Professor R.C. Mittal sir. Sir has elaborated each and every concept in a very detailed manner. So thanks to all of you.
Now, should you have any suggestion for the next 2 lectures? I can welcome. I just try to do that. Otherwise, my second lecture is on numerical solution. I mean to say precisely finite difference solution of heat equation in 1 and 2 dimension, where concept of stability, convergence, consistency, and how to find stability will be discussed. My third lecture will be on the meshless method and RBF, by RBF, radial basis function. If you tell me right now, then my efforts will not go in waste. If your suggestion I can include, but if you tell me the right moment, this will be better.
So any suggestions from the participant side regarding the lecture content, as very well said by Professor R.C. Mittal sir? So I think, sir, this is perfectly fine schedule for all the upcoming lectures.
So that's all. Thank you very much.
Thank you very much.
Thank you,
Thanks
sir.
to all of
Thank
you.
you, sir.
Thank you.
So can I leave now?
Yes, sir.
Yes, sir. And thank you
Okay.
very much, sir.
Thank you. Thank you.